Hello and namaste. Welcome to one of the next important lesson called OOPS. OOPS stands for Object Oriented Programming, and generally in the industry or even in the companies, abbreviation we say it OOPS, which is equivalent to another OOPS that generally we use as a slang. So, what is OOPS and why is it important? So, in a structural programming language or in a procedural programming language, where what used to happen, we used to write the code in a very we would create different files for different tasks or entities, and we would write code inside this. So today this entire lesson, I'll explain with an example for food delivery business. Okay, let's say we were implementing this in C. Generally, how it would be done is you will have one file for say user, and probably will have one for the delivery agent, and then you will have one for restaurant, right? Like this you will have, and then maybe there is one utility file, then for one for network, one for security, one for authentication, and then in this you would go ahead and inside this you would know probably you'll have a struct here, you'll have a struct for this entity, and then you will have bunch of methods here, bunch of methods saying sign in, then sign up, then place the order, like this, right? You would have these methods in the structured language, and then you will have an application file, and in this application file you will include all these file where you can invoke these methods, right? You will invoke saying user underscore sign up. But for a smaller project with just one or two developers and probably 10-15 files, it may not be a challenge. But imagine where you have hundreds and hundreds of files and hundreds of developers working together, it becomes immensely complicated and challenging, and you will really struggle to know what files exist, what entities exist, what operations you can perform, and there won't be any restriction. Like say our application would can access any of these files, call any of the functions involved, and this would be more error prone because in any company the software shelf life, if it is successful, the shelf life of software can run into decades, and many people who originally wrote the code may not be there even in the company. And why some good developers try to maintain good documentation, but generally documentation is a challenge in software industry. So a lot of the people would struggle to know, okay, why it was done this way, why this is being called from here. There's a lot of such things, and also no prevention, like anybody can go and access, anybody in this is not customer, any developer, while adding new features or modifying existing features, they could just randomly have access to every part of the source code and they can invoke it. So this led to a lot of confusion, chaos, duplication of code, all of these challenges. And that is how the birth of object oriented programming came, which is primarily has two important things. So one is called class and the other one is called object. So class it is like a template. Class is a template where you define that class and you define it for what entity it is. Okay, so generally this entity could be, if it is generally it is representing some persona of the product. Persona is basically different type of users. Like say in a food delivery app, it could be just the customer is one persona, then the delivery agent is the another persona, then restaurant is one more, like this. And it can also have classes where you will have basically the business logic, and those classes could be for operations. You could also have classes which handles the underlying layers, like say DBA, database or database access, right? Usually, they call it DAO, and then they may have classes for networking, etc. So at the top layer, you're thinking in terms of the users, then you're thinking in terms of operations, then you're thinking in terms of database, networking. Different aspects can be organized into different classes. And then within this class also, if there are, for example, customer, agent, restaurant, all of them share one common thing, which is they all have name and they all do sign up, right, using their name and phone number, and they all do sign in and sign out, sign in and sign out. Now, since this portion is common, irrespective of what these entities will do, then there can be a common entity called user, and this user will become a class. And there is a concept of inheritance where all these classes can inherit from user, and they will get all this source code for free. Means someone else in the company would have written it, and the developers who are implementing these classes, they don't have to write it. So in terms of writing the code physically on the file, this is how it gets very streamlined and organized. And one of the important thing would be, let's say you have customer, which is inheriting from another class called user, and then you also have the delivery agent. That agent is also inheriting from user, right? So now within this, you will have all the attributes. You say attributes or properties or parameters. You will have these attributes of this user, where let's say it will have something called name, it will have home location, it will have that mobile number, etc. Then it will have some of the common functions like, sign in, sign up, then search, then place the order, place order. Like I said, since sign in and sign up are common, they very well be coming from this base class user for both agent and this one. See, agent also, some of these could be common. Other than that, it will have something request ride. The agent who deliver, they will say request ride or ready for ride. Then they will say accept ride or reject ride. They'll have accept ride or reject. Then they will say acknowledge the pickup, right? And then they may also have functions to say that they are on the way and send the location. And they finally can have something called delivered that product, right? So what you see here is generally these nouns can be these classes, and the verbs or the actions can be these functions or methods. Generally in textbooks and some of the blogs or YouTube videos, what I see is people over index it on very simple examples like say car and bike or animal and dog and horse. But what happens is, students will understand it like dog and horse and car and bike. But when you ask them saying, can you design classes for a real world example like say food delivery app, they get really confused. They are not able to translate that understanding into a real world business scenario. So this is where I feel that we need to teach people more about, take real world examples. I mean, food delivery app is an example through which I'm trying to explain this concept. Similarly, take other examples and say, okay, these are the classes that it would have. These are the attributes that it would have. These are the functions or the verbs or the actions which will become functions. Now, there could be something like, private and public, which is if these functions are exposed, they are called public. There could be a private function. For example, the customer want to see the orders that they have placed in the past, right? So this customer can have a method saying past orders, and this method could be private past orders. So this is something only a certain part of the code where is this function should be allowed to access, whereas someone else, like say restaurant or the delivery agent, should not have access to this. So all of these access controls can also be put in object oriented programming languages. So once you understand how, for say a food delivery business, the usually the nouns are the classes and then actions performed by those actors can be public functions, then you start getting some rough idea of, okay, in the first part the class get helps you to organize code in certain way, right, where each file is an entity, and this is about just the actors of the product. Now what about the backend things, like say interacting with database, interacting with network calls, interacting with the payment gateways? Now those can also be classes which would have again attributes and public and private methods, right? With this context, now let's see what is an object. So as you learnt in programming language, where we say you declare a variable like this, where you say this is the type, right? So this is the type and this is the variable. Generally in programming languages, in Python we don't do it, we directly say a is equal to 10. So here automatically this is the name of the variable and this is value. Okay, now in case of Python, all these data types, like say your int, your float, character, string, all of these are also objects. So what does objects mean then? So objects mean when your program is compiled or interpreted and it is loaded onto the RAM, and that process starts executing, and the space need to be allocated on RAM. So for every object in memory, it creates an instance, that instance of the class, and that instance of the class is an object in memory. For example, if you say, let's say you have a customer as a class, and you can create the objects of it, as many objects as you want. Let's say C1, C2, C3, you can create multiple objects like this, and each object in RAM in heap memory. So let's say this is RAM, then you have this is your process that is loaded, and in this process you have heap memory, right? So in this heap memory, for every object there is a space, like this in the heap memory. So all these objects get allocated in heap segment or heap memory, and programmer can decide when to free them, and if you don't free them and it's being not referenced, there is a memory manager which internally runs garbage collector, and that garbage collector would go and free all these unused objects for which are not being referenced in the future. So we will not get into memory part right now, but let's understand what is an object. So the object is during the runtime when it is executing. For these classes, you can create the instance of those classes, and those instances in memory which will hold that real data, they would be present in the heap memory. And then of course you have the code associated with that, which is also loaded in the code segment, and those functions can be invoked to do operations on that data. So you can, then there are some special classes in other languages where they are called static classes, where you do not create these objects and you only can directly use it, almost like a similar to other structured programming language. It is just a code organization technique and you can directly access those methods. So we'll cover that at a different point. But why is that I'm suddenly from in this Python series, why is that suddenly I'm jumping to object oriented programming? The reason is, even if you want to use a simple data structure, let's say you want to use array, in Python the arrays don't exist, they have list, and list is an object. So you are creating, when you're declaring a list, you are actually creating an object. And even when you are creating an integer variable like this, you are still creating an object. So if you want to practice, say, loops, for example, we want to learn looping. So you want to loop over list, but then you should know what is a list, right? So I could have said very well that, okay, list is basically an object of the class. Then it would have confused you more. Okay, what is this class? What is this object? Since it is very fundamental to Python, where all these even primitive data types, what we call as like an integer or character float, they are also objects. So I thought first let you get an understanding of what is a class, what is an object, how to access the attributes of that class, how to access the methods of that class or the functions of that class. If you learn all of this, then learning, loops, and then even learning these data structures would become very easy. And generally, object oriented programming is taught after all these loops and conditional statements and other concepts are taught, but I'm just front loading it so that you can understand those concepts even better. Okay, now I will start showing you notes that I have prepared, where we can see how some of these things can be done, and we'll walk through the coding exercises. But I would like to highlight some more points, which is, if you are somebody who has coded in, say, Java, C#, or C++, there are some distinct things with Python, which is, say, let's say you have a class called user, right? And in this you have methods here. So you have a method, say, let's call sign in, right? And you are taking username and then password. Generally, in other languages, you also have attributes here. You define those attributes. It could be, name, int name, int age, right? In mobile number, some of these attributes also you will have it here. But in case of Python, it is not compulsory that you declare these attributes here. Once you create an object of this, let's say you created an object for this user class. User is equal to u1, right? You created this object. Now you can directly assign these attributes like this. un.age is equal to 10. So you could add any number of attributes to that object, or remove those attributes, and it cannot, the list, like say u1 can have age and u2 can have something else like date of birth, DOB. So under the hood, what Python does is it just creates a dictionary, which is again a specialized data structure that we'll learn in our subsequent lessons, where everything is like a dictionary, is where you have something called key and value. So key and value. So what happens here is that every attribute that you are adding is added as a key. Let's say you added age. Okay, age is 10. Then you added DOB, right? So DOB is something. Then you say height, like this. And this could be for, say, one object. But if you don't do it for another object, it is absolutely okay. It can have its own set. So here it is showing these attributes as a combination of key value pair. Now this can be very problematic, because if large number of people are working on a code base and anybody can add or remove attributes to your object, really the people who are coming from Java or C# or C++ background will scratch their head and say, what the hell, what is this? This would become like a chaotic madness on a large code base. So to prevent that, Python has something called slots. So if you define slots saying, okay, I will allow only name and and age. So if we define this, then it won't allow the developers to add attributes to that object or remove it during the runtime. So there is some preventive mechanism, and this is what the built-in classes like, say, int, list, they all use it. So they define slots so that you cannot change it. You cannot modify, or you cannot add more attributes to those objects. So we'll code and try all these aspects and see it through the coding. But trust me, in modern days, other than some writing script for some backend things, let's say you just have to write 50 lines or 100 lines of some backend script, To do certain things, probably people will not use classes, but most of the code that is written, object oriented programming has become a very important way of writing code and organizing software, and it empowers developers, good number of developers to come together and work in a decentralized way. At the same time, it substantially reduces the errors that used to happen earlier. So let's look at our notes and try some try some hands-on coding. Okay, let's try some hands-on workshop, and there will be another video on object-oriented programming with more details around inheritance, and then do some real-world projects with multiple classes. We will have that covered in a separate session. In this lesson, we will learn enough which is sufficient for you to make further progress with respect to loops, with respect to using some of the data structures like lists and dictionaries. So this should set that ground and context. So let's see some of these nodes that I generated using LLMs. What does it say? So why is that OOP came into industry? As like we discussed, difficult modeling real world entities earlier in procedural programming, repeated code and hard to maintain logic, and tight coupling between different parts of the program, right? So it try to address some of these, and these are how it solves. For example, repetitive code and all get put into certain classes. Then complex logic, say there is very clean separation of the code based on the entities or based on the underlying modules or operations that we perform, like say database operations or network operations. Then modularity with help of objects, and it is very intuitive to understand for developers when the code is organized in terms of classes, right? Then roughly somewhere in around 19 brief history of this, it was introduced in a language called Simula in somewhere in 1967, and it gained popularity in 1980s with C++, and then finally in Python this concept was introduced in the year 2000. So what are the two main core concepts that we learned? One is a class, another is object. So for class, it is basically a template. It is a template, and whatever instances you create out of it are the objects. So to tell in the languages like other languages like say C, Python, Java, so your data type int is like a template, and the variables that you create are instances of it, right? So here you are defining a user defined type. In fact, in industry when we talk, right, so we say it's a user class is a user defined type, right? Struct is, in case of C programming, they say struct is a user defined type. User in the sense here is the programmer or the developer, right? So let's go ahead and implement a simple class called customer, and this is what the syntax would look like. So you have the keyword class, and then you write the name. Generally you start with the uppercase letter and you followed by colon. Now this constructor is not compulsory. You can write it even without a constructor directly this, and that would create a class. So let's do that. Let's go ahead and implement a class here. Class customer, and under this you can define a function saying place order. So this is the syntax. You have to reference that instance by writing this self, and then let's say name of that item. Okay, so I am just not implementing any logic. I am just writing here saying order placed. So your class could be as simple as this, right? You have a class, you just have one method, and this could be your end of class, and now you can you can create the instance of it. So you can say customer 1 like this, and You can actually create like this, and then you just have to put these parentheses in front of it. So you declare the variable and then you write the type. Okay, it's other way around. So you basically say customer 1. You don't have to write the type in Python as we do it for int and other as well. You write variable and then you write just the class name and like this. That's it. So this creates the instance of the class customer, and this can be called as an object. So here, what is the object? So here I'll write in comment customer 1 is the object and customer is the class. Now how many objects you can create? As many as you like. As many as you like. And each one of this, they get allocated, the memory gets allocated in the heap segment, and this code that you see is in the code segment. And as you call functions, if there are functions and then you're calling those functions, then those function calls, that state that get remembered in the stack segment. So let's go ahead and invoke the methods, right? Let's go ahead and invoke this method. So when I say customer 1, and in any modern integrated development environments, the moment you say dot, it will show you bunch of things which are there along with this, and you can clearly see that this place order is also there in this list. You can see it this way. So when you say this, at the top, do you see this square color box, and you see this place order function, and all these which we did not define, and they are still there because all these classes, even though we don't write it here, they all inherit these functionalities from another base class, which is kind of a parent class to every class that you write in Python. So that base class has all these things defined. So by default, whenever you declare a class, it is inheriting from that class and it has all these functionalities implemented. Now, wherever you see these boxes, where this white color and this color, it is differentiating, and this underscore underscore indicates that you should not call these are private. These are the access modifier. In case of Java and C++, you know, uh, the access modifiers are very strict. You will get a compilation error straight away. In case of Python, you will not get those errors. Your interpreter will not complain. You can call these, and even when you implement these classes, you can call these. It is just a convention. In case of Python, all the notion of whether it's public, private is just a convention, and developers have to use their common sense to make sure they honor these conventions in the larger interest of that project and their customer and their data. But in case of languages like Java, you will get compiler errors. It won't let you compile the code itself. Okay, so that is why those languages are way more safe when it comes to security and other aspects. So here I'm going to invoke this function place order, and it is accepting a parameter called name the item, right? So I'll say initially one of the item is just say pizza, and let's do one thing, order placed for, let's print that name so that you know where that call is coming from. So you'll say name of that item. Let's rename it saying item name. Okay, similarly customer 2, customer 2 is placing the order, customer 2 dot place order, we will say roti. Let's Okay. Let's say you want to do one more thing, which is you want to invoke this function now, customer 3 dot place order rice. Or let's say customer 1 only want to place multiple orders. It is just, or maybe instead of place order, we should have said add to the cart or something like that, right? That makes more sense because you cannot place order multiple things. I will rename this to, instead of place order, we can say add to cart. Add to cart would be more sensible. So we'll say add to cart, add to cart. Okay. Now here I'll say pizza pasta. So customer 1 is invoking this for each of the item, add to cart. This is a very crude implementation just to demonstrate to you how these things would work. So now there is no data storage. If you see here, there is no data storage at all. It is just having a function that we are invoking. So now let's run it and see what happens. So you can see that order placed for pizza, pasta, roti and rice. Now let me debug and show the code and you will understand how these things would work. So initially interpreter sees that this is a class, it will skip, it will go to the next line. It will also come and see what was inside this class. So you have this methods, then it finished running through the class to see what and all it exists in this, and it came to line number 8. So Python interpreter process it sequentially in this file. So now when you say customer 1 is equal to, you are you're writing the class name with this open and close parenthesis. So it is saying this is a special variable, and in the watch here, let's write customer 1. So what is the error we are getting? We are saying customer 1 is not defined yet, right? The moment you run the next line, you see that something happened. So it says customer 1 main object at this address. So in heap memory, a object got created, a memory got allocated, and you can see that there are some variables here. There is this special variable dictionary that I was talking about, which is empty right now. Okay, there are no items in it, right? This underscore dictionary. And what does it has? It has this function that we added, which is add to cart. Okay. So it says bound method customer add to cart. See, when you debug the code and see what is there in this object in the memory, how is it organized, and you may be surprised, oh, where did these special variables come from? They all came from the base class that this class inherited, right? You will get more conceptual clarity and how these things work, and you will remember and retain this information for longer. So now let's go dive into this function. What happens? The call jumps here to wherever that function is implemented, right? And then you see the print statement on the console now, which is here, order placed for pizza. So similarly, I'm going to run the next line. I will not debug it again. I'll just step over it, F10. Then now customer 2, right? So this is interesting, where now customer 2 is created, and in the watch you can see that customer 2 is now created at a different address. Customer 2, look at the address of the first object, which is an instance of the class customer, and then this is the second object, and both the addresses are different, and they both are allocated memory in the heap, right? So like this, you can see you can create as many objects you want. Now one of the interesting thing which probably don't exist in other languages is that I can add the attributes like this. I can say customer age is equal to 18, then customer name is equal to Mahesh. Sorry, customer 1, not the class, the variable name. Okay, and then I can print it and see, print customer name is, so I can just write it saying customer1 dot name like this, and then I will say and age is equal to customer1 dot age. That's it. So this is very strange and very unique probably to Python. I don't know if any other language supports this where you add attributes like this. So what is happening? Let's see it through debugging, and it'll be very interesting. So let's go through the next lines. Yeah, we are here now, and you have already customer1 in the watch. Okay. And one thing that I would like to show here is inside this customer, under special variable, there is this variable called dictionary. Okay. And right now this length is 0 in the dictionary. Please observe that length is 0. The moment I run this line number 15, what will happen we can see. So I'll run through these two functions. Now is the time to see this dictionary. So this is a dictionary and there is this length is equal to 0, and I'll run the line and you can see what happens. So length is 1 and an item is added to this. Age is equal to 18. Then add one more. So it added name is equal to Mahesh. So technically the attributes inside the objects in Python can be added dynamically at the runtime. And this does not have to match with the another object. And if I try to access it in another object, it will fail. So this is a very strange way of attributes in an object oriented programming language. And people coming from Java and C# would be stunned at this, right? So what I mean here is then now customer 2 can have a whole different set of, or the way it is being numbered, right? You can say full name like this, and this has no bearing or no impact on the other object, and this would have no bearing on any other object. So it is something like this. Now this can cause lot of confusion for developers, and if they all start adding attributes here. To streamline this, what generally is done is there are two techniques. So one way is to define a constructor. Okay, they define a constructor like this, where you say underscore init and self, and if required you will pass certain values like say name and age, and here under this it would be written like self dot name is equal to name, then they'll say self dot age is equal to age. So in this instance of this class, which is an object, there you are setting these attributes, name is equal to this. Now what happens if you do this way? So then when you are creating this you have to pass those values. Okay, so let's try to run it and see what happens. Now it is saying interpreter is giving an error. It is saying that the customer init is missing two required positional arguments, name and age. So when you are creating these objects, now I have to pass them. So I'll say Mahesh and 18. Then here also, as we create more objects, we have to give those names, Sangeeta and 18. Customer 3, Santosh, 20. So now let's run it. Now there is no error, right? It worked, but there is still an issue. I'll show what it is, but let's debug it and see this one. So what happens? So the breakpoints are all same. Let's debug it. Now initially the reading of the class is happening by interpreter. Now comes the part where you create the object or instance of that class. So when you now go inside this, it comes to this init method. So here again it's time to watch what is happening in customer 1. So since customer 1, that name is not visible, you can say self. Okay, so here you will see special variable, and you see that the dictionary is empty right now. Okay, in the watch I just added self to the watch. So as you run this line, it again get added to the same dictionary that we saw earlier. Okay, here name is equal to Mahesh, and then if I run this, the age got added and we came out of that function. Okay, so here if you now do customer one, now customer one is accessible. You can see under function variables you will see these names, and under special variables you will see that there is this dictionary inside which you will see those values. Okay, so let me clean this and add customer one. You can see that under underscore underscore dictionary these values are stored. So instead of every developer trying to set these values after creating object, then they would have created with different names, they would have done it differently, they would have added more or not added something, correct? The developers would have done it, would have been more error prone if we were doing it like this, what we have done here. Okay, so to change that, what is done is a concept of this constructor exists where you can define these, and anybody who is declaring the class have to pass these arguments. However, this does not still solve the problem. I'll tell you why. Now let's go and debug the next line. Now we are adding age. Okay, already we had added age, and let's run it and see what happens. It happily takes in. It happily takes in because we are overwriting it. It would take in, it will think that you are trying to change that key and value, so it would happily accept that what you are doing, and if there is a full name it would accept that also. So it is something like slightly better than the last option of letting developer do whatever they want, but it is still not, you still cannot prevent the errors. Okay, so this is where the third concept that exists, which they call as slots. So let's see the syntax and how it is done. I'll stop debugging. To prevent this arbitrary attribute assignment, so those values you add the are called attributes, and these arbitrary attributes assignment you can prevent by introducing, there is something called slots. So in the class, if you define like this slots and say that only these attributes are allowed, then only these will be allowed. Anything else, if somebody is trying to add, then it won't be allowed. So if you define slots and if you define constructor, then everybody who's creating an object, all the developers, they'll be compelled to first of all call the constructor with these parameters. Second, they cannot introduce any more attributes to that object for that class at the runtime. So this is a preventive mechanism, and under the hood, as I said, it uses dictionary, and by adding the slots here you are preventing it from adding any further attributes to it. So let's go back to our code. So here basically you have to define this slot, and you say that you allow only name and you allow only age. Okay, so I will try to change it as, let's say, current age, and I will make this full name. Okay, so remove these breakpoints and then set just one breakpoint here, and then try to run this. Let's see what happens. Okay, now we have added the slot, and this attribute is different one, and I'm trying to add that. Now ideally the interpreter should throw an error and say that no, this is not allowed. Okay, the customer object has no attribute current age, no dict for setting new attributes, and it also, that dictionary is not there, is what it is saying. So why don't we go into the memory and see what happened here, right? So go to customer, go to special variable, and you can see that the interpreter has understood our signal and it has removed it. You don't see that underscore underscore dictionary here in the memory, so it has been removed. Okay, so that is how it is preventing it from adding anything like this. Okay, and since you have added slot and you have created a constructor, now there is some guarantee that the developer should create it with this. Now why is that I'm telling all of this? Because we will use lot of these objects of built-in classes or built-in types in our subsequent lessons, and this lesson sets the good ground to understand classes objects at very high level, and without getting into object oriented design patterns, then inheritance and all of that. It gives a very good overview of what it is so that we can start using it. So in case of access modifiers, generally it is called a convention. Like I said, in case of other languages it's strict, here it's a convention. So if it is public, you don't put anything. If it is protected, you write it with single underscore. If it is private, you write it with double underscore. So the dictionary there was a private, so that's why it was being written with double underscore earlier. Okay, and here is an example where you have it here, where something is public is written like this, something private is written with a single underscore like this, and something which is protected is written with two underscores. So it is just a naming convention here, right? It is just like a naming convention inside this file. Like say for this customer, we can very well do like this: self dot underscore rating. I'm just saying that this could be one of the example. I mean, one of the way we can do, and that underscore is here appended at the beginning. So location and rating, right? So we'll add, let's say location is private is equal to Harluru, or let's say HSR, and then what is this? So this is private, and the protected could be self dot underscore rating. Okay, the rating that this user has given. So that could be private, or say sorry, protected, something like this. But nothing would prevent us from accessing these values. It's just a convention. That's why it is called convention. Okay, so what are the best practices? Definitely use initialize always. Then keep sensitivity of the data by at least that convention need to be followed, which is private, which is public. And then definitely use the slots so that people don't add and remove attributes to your objects, right? And then classes should reflect the real world roles. You should not declare a class saying class 1, class 2, class 3, class XYZ like that. It does not make any sense. So it should reflect some entity in the real world. Okay, so with this inheritance is a simple inheritance. Will have a separate session on going to the depths of it, but at very high level I would like to show you how the syntax is there, because all the classes that you declare or what you use, there will be some form of inheritance. So this is your base class called user. Okay, now the customer is inheriting user because every base class has something called login. Okay, so and what happens is this helps in code reusability, and you can directly assess it. See, when we declared our customer class, there were a bunch of methods that came which we didn't even implement, right? So it came from the parent class, the base class. But here the syntax here is you write the class name and in under parenthesis you write it. So don't worry, I may be sounding like I'm rushing through this right now, but this is not required for your next 2-3 lessons. We'll get back to this with the proper project and understanding with object oriented design patterns and inheritance and all of that in another session. Okay, now what are the built-in class types that comes along with Python interpreter? When you install the Python interpreter, all these get also copied to your machine. So the basic data types, int, struct, float, all these are classes in Python. As you are declaring variables of that type, you are actually creating objects of that type. So whenever you say order ID and you do this type check, which we had done in our variable class, it shows that this is a class. This is a class. And related to memory management, as I mentioned, all these objects go in heap. The class definitions and methods go in code segment, and stack keep all references and function calls. Okay, so this portion we have already covered, and the memory allocated for these objects get freed up by garbage collectors. So here is the difference between both procedural and object oriented programming. The memory management happens through garbage collector here, and here it is through malloc and kelloc, and of course Python is interpreted, and here procedural C is compiled. Then method dispatch handled at runtime, static calls and faster execution. Then in terms of security, there is some amount of still encapsulation in object oriented programming like Python compared to C. Okay, so with this I think you can go through these notes, but one of the important summary here is the purpose of object oriented programming is to mimic the real world scenarios. Then it creates the template for all of that, and it controls the visibility of data, and indirectly it controls the visibility of data, and it segregate all the related data and functionalities into one part. Then memory allocation also, the memory is nicely allocated in heap, and the only if you have access to that object, then you can access that data. If you have access to the instance of that, or the variable which has access to that instance, only can access that data. Like say customer 2 object cannot access customer 1 object's data, so that isolation is there. So only if you have that handle, then you can read that data or call the function calls, otherwise you cannot. Okay, so with this I think this sets the very good context for us to move on to our next session. See you in the next session. Thank you. Namaste.